Now, let us take up the flash calculation today in this video. Okay. So how we do the flash calculation. In the previous video, we have seen how to calculate T bubble and T dew. So definitely we know that in between these two temperatures only, that if we consider this particular temperature, and of course pressure is fixed at 101.325 kilopascals, right? So this is 3 to 5 kilopascals. Now the system here is acetone and plus ethanol. This is what we are working on. So let us again, let me confirm here. So this is acetone and ethanol, you can see here. So this is what we are able to understand here. So see, acetone and ethanol. Okay. So let me rub all this. So we have to work on today now on how to calculate the flash operation in this. Okay. Now, before going to that, is an important feature in the previous video also I have shown you how to display, or in this particular area, suppose say this stream, it has some temperature, some pressure and flow. Okay, flow, let me write like this. Flow, this also has temperature, pressure and flow. This also has temperature, pressure and flow. But here in this flash, very important here is what is the phase here. Okay, if we can get it or not, we don't know, but see. And very important, flow here, this is a vapor flow. Flow here, it is liquid flow. So, and the composition here is, we say Y, and the composition here we say X. So these are the this is known as a feed. Okay. Hope you are able to understand. This is known as feed. It contains the mole fraction ZF. Okay. So these are the things we are actually trying to understand. But I want to actually display this particular information on the flow sheet. So go to the settings and object properties, and here you can see the material streams, display temperature, display pressure, display molar flow, and you can say these are the few things which are readily available. If we want, probably we can actually do more also. It is showing, it is actually showing, and you have here. Let me see whether we have a flash or gas liquid uh, operator. Okay, so we can also come up that particular thing later. Compound separator, and then we have many things here. Okay, now let me say fine, and then now you see. So this is all coming here straight away. So let me rub this off, all these things which I have written in the palette, or this is flow sheet window. Now let us go to the our workout. So now, so let us actually click this. So this is our feed input. So let me change this as feed, then press enter. See here, generally whenever you use certain input, you have to press enter and ensure that it has been accepted by the system. Now the what is the package chosen is, or the thermodynamic package is Wilson, and the stream conditions now is we have to take, pressure is fixed here. This is pressure, but how much is the what you call T bubble and T tube? It should be in between T double and T tube. So previously we got a certain value. So it is so in order to actually again go and immediately let us see. Now I take this pressure and vapor fraction because I know pressure is fixed. I come down and then I make it as vapor phase mole fraction to be 0. That means entire thing is liquid. So entirety it should be liquid. So vapor phase mole fraction is liquids. That means we are finding bubble point temperature. So bubble point temperature is given here as 62.138. So 62.138 degrees centigrade. Okay. Now next again, if I say I convert this and then I come down and I change this to 1, means entire the feed mixture whatever is considered is to be as, so this is now a dew. So that means 67.4331 degrees centigrade. Okay. So what will be the temperature in between these two? Now again, let us go to our flash spec, go to the temperature pressure, and then this is the what do you call, now you give certain value between these two. Let me say 64, and then of course press enter. Yeah, so I have pressed enter. Now you can see, let me actually what do you call, make the screen bigger. Yeah, so you can see this. Yeah, now you see there is a change in the molar flow here. See, feed is 1 kilomoles per hour, temperature is 64 degrees centigrade. That is what we have specified. And the vapor side is a vapor, temperature is 64, pressure, and you see the mole fraction here as 0.45 kilomoles per hour. And in the liquid side, that is bottom, 64 degrees centigrade, 101.33 kilopascals, and 0.55 kilomoles per hour. That means both two phases are being formed. That is what is very important. But here, when you come to the gas liquid separator and you see what is the temperature here, it is not showing at 64 degrees centigrade. That means what you have to do, click on this flash, scroll down to the bottom, and then you see override separation temperature here. You have to do what? Click on this first, and then change this to 64, and again click on this. Oh, sorry, it's again not taking. Now you have to press enter. 64, press enter, again override. Now it will be fixed. Okay, now you see this entire. Now if I come to this 64 degree centigrade also, that means even in gas liquid separator, I see this one. So whether my result is correct or not, that means I change, or rather, what do you call? I go to this feed, and then I change this entire thing as again I go to pressure and vapor, and then I come down, and then I say this to be a 0. So that means what? Entire feed should come appear as a liquid, right? Now you see kilomoles per hour is 1 kilomoles per hour. You can see here this entire feed is coming as a liquid, and here it is you find a 0. Okay, that means there is no vapor flow. Similarly, you can find. So this is known as bubble point. At bubble, this entire equipment is operating at bubble point. If entire feed is going to the vapor, that means entire flash operation is taking place at what you can say, taking place at dew point. Okay, good. Now we'll go to the next one and see.